All right, so we're going way back to the beginning of the school year with banking. And I just wanted to throw out there that we did start with simple interest formulas, but that the simple interest formulas can be rewritten where I manipulate and show it isolated for each different variable, but they're all written as a starting base of I equals PRT, principal times rate times time. But simple interest is pretty uncommon in the real world. After we did the banking chapter, we realized that most things are compound interest. So we're going to be looking at these 4 formulas today, the big mama formulas, to make sure you can still plug into these and get these if needed for the final. And what was the hardest part for you guys for banking? Which formula to use when? And so we're going to write down an example of each one of these big ones. So I'm over to who? Was I at Carla? Whose turn was it? No, you guys had already gone. Adrian went. Am I at Perla? Okay, great. So starting with the first one, Cody deposits $2,200 the summer of 8th grade to save until college. If the savings account earns 2.5% interest compounded daily, what is the balance after 4 years? So this is just a straight up compound interest formula. And it's already listed there for you. It's this guy right here. How do I know when it's straight up compound interest? It doesn't say that he's depositing anything monthly. That would be a periodic investment, the bottom 2. It doesn't say how much would I have to deposit to have a certain future number. That would be future. So we go with regular basic compound interest. So here I go plugging these in, and Perla, you're going to help me with what things go where. So for example, when it says P, the principal balance of the money that I'm depositing, how much money are they putting in the bank? What's my P? 2,200. I'm going to go ahead and put that first into my equation. Then it says 1 plus the rate over N. What's my rate going to be that I plug in here? Good. Now, notice that she's already changing it with a decimal, so let's talk about that here. So if the original rate is 2.5% and I bump the decimal twice left, Perla, read me what we're going to actually put into this formula. You got it. 0.025. Is that what you were thinking? Now, N stands for the number of times compounded per year. Number of times compounded per year. That's my N. Do you remember what daily would look like in that denominator? How many days there are in a year, Perla? 365 is my divider right there. So the compounded daily shows up as divided by 365. And then to the power of N times T. And so we just did the 365. And then my time, how many years are they asking us to do this for? For 4 years. Okay, you guys are ready to go into Desmos? You're going to keep your heads down looking at your computers, not peeking up at my screen, and then look up when you've got it to make sure. I'm going to give you guys a second. Some of you are still writing this. So 2,200 times 1 plus 0.025 divided by daily 365 to the power of 365 times 4, NT. When you're done, look up here to see if you got it. If there's something wrong with yours and you need me to come check your computer, let me know. Oh, that's so tiny. Anybody need me to look at theirs, see if they got it? Thumbs up if you have that answer on your Desmos. Okay. All right, so go write that in, 2431. How am I going to round that? Point how many cents? 37 cents. Do you guys see how it rounds up? All right, final answer 2431.37. So number 1 is an example of the plain compound interest formula. If on the test you read one that sounds like this example number 1, you can go, okay, this is the formula I'm going to use. Here we go to number 2. I'm now moving over to Francis. Francis, Mike wants to open an account for his grandchildren that he hopes will have $80,000 in it after 20 years. How much must he deposit now into an account that yields 1.75% interest compounded monthly so he can be assured of reaching his goal? So this is called a lump sum deposit, meaning we want to put a chunk in the bank at one time, not a periodic deposit, which is how most people save. Most people put a little bit away every month for a long time. But this is a lump sum. I mean, maybe a grandparent has a lot of money they've saved at this point. So to do the lump sum formula, and by the way, it says, how much must we deposit? That's always, our deposit amount is our P. So I'm going to be looking at the formulas for which one has a P equals, not a balance in the future, but which one has a P equals. And so I go up there and look, here's my present value of a single deposit. How much must I deposit presently to have a certain amount in the future? So this guy right here is going to be our number 2, and we're just going to go plug in. You're going to tell me what numbers. Let's write the formula first. P equals B, that's my balance that I want, over 1 plus R over N to the NT. Where am I getting this from? I'm getting this from right up here. All right, so Francis, what am I going to plug in for a future balance that I want to start? Good, go ahead and put that 80,000 as your numerator to start. Remember, Desmos doesn't like commas. And that comes from right there. Okay, next it says over 1 plus the rate. This time, what am I going to plug in for that rate? Okay, good. So you said, and technically don't need the first 0, but you could say it. And then compounded monthly, how many times a year does monthly happen? Yep, by 12. And then to the power of NT, so my N we just got was 12. And my time, how many years does he have to have this ready for them? 20 years. So my N comes from the compounding, and my 20 comes from this time right here. Take a minute to plug that into Desmos to see if you remember how to do this guy with that big thing in the denominator. Bless you. And by the way, this time, if 12 times 20 stands out to you as like, oh, 12 times 2 is 24 out of 0, that's 240, you are welcome to just type into Desmos the power of 240 without typing the 12 times 2, if that makes sense, 12 times 20. Okay. How'd we do? 80,000, 1 plus 0.0175 divided by 12 to the 12 times 20. How'd you do? Got it? Read me that answer. Good. So equals 56. .42. Okay, I'm going to go back to the Desmos real quick, just make sure that people understand how to get this one. I know it's tiny, but did you get that whole 80,000 on the top, and did you get that 1 plus thing on the bottom? Okay, so we've used the big formulas number 1, we've used big formula number 2. We now need to go practice the last two, which are the future value, also known as periodic investments. So I'm at Anthony, and then it's going to jump way to the back again to start over, so you're prepared and not shocked. Okay, let's go look at the next one. This one says Jenna wants to get an wants to go on an $8,000 vacation in 5 years. She has a bank account that pays 2.25% interest, compounded monthly. How much must she deposit? Ding, ding, ding. Each month. So this key word right here is what tells us that this is going to be periodic. It's going to choose from those bottom two formulas. And because it says how much must she deposit, when I go look up here at my choices, this is the future value of a periodic deposit, and one's called the present value. How much presently must I deposit? I'm trying to find the P because I know I want that balance of 8,000 in 5 years. So I'm going to be using this big guy at the back. This is my number 3. B times R over N over 1 plus R over N to the NT minus 1. So let's go write that. The present value is B times R over N, or 1 plus R over N to the NT minus 1. And I don't have these formulas memorized like from teaching, I kind of do, but we have the ability to look these things up. It's why it's an open notes final, so that we can refer to resources like in real life. Why would I ever use this formula? I don't know, if I'm a banking manager. Otherwise, your bank's going to calculate this for you. But maybe we want to see how much we would have to save. Okay, go start plugging that in. Anthony's going to help me with what should go where. Anthony, how much is the balance I'm going to want to have in the future?
8,000.
Good. So we're going to start, with that 8,000 as my B. All right. And then what's the rate going to be? If they told us 2.25, what are we actually going to plug in?
0.0225.
Good. .0225. Now this one's going to be compounded monthly. So what's my N? What's my denominator there going to be? 12. And notice there's no power there. Now we go to the denominator. 1 plus the rate, you just got it, over compounded monthly, you just got it, to the power of 12 compounds. What's my time? How long until I'm going on this vacation that I want to be saved by?
5 years.
Good. And then don't forget to go down out of that exponent and minus the 1.